続きまして、九州大学I²CNER佐々木一成燃料電池部門長より Fuel Cell Research Current Status and Future Perspectives Towards Carbon Neutral Society と題しての講演をいただきます。どうぞよろしくお願いいたします。
Thank you very much for kind introduction. Before I start my presentation, I'd like to thank Petros to giving me the good opportunity to present how we want to work in the field of fuel cells. And actually, I want to divide, this presentation consists of actually the three different parts. At the beginning, I want to explain what is actually the current status of the fuel cell, and especially for residential applications, because Hirose-san has explained very clearly how the situation in mobile automotive applications. And second, I want to explain what could be the important issue, and I was just mentioned the case study, what we have done in the last 2 years. And finally, I want to explain how we have prepared for this I²CNER project, because during the 2 years term, that is actually very important preparation time, a preparatory time for the future research activities. Of course, Japan has taking a leadership to reduce the CO2 emission, and that is also important topics and research issue in the I²CNER activities. And especially we need also advanced energy technologies to reduce the CO2 emission. In addition, due to our serious energy problems, we should also increase the energy efficiency, and of course the fuel cell is one of the key technologies which can also contribute to this important issue. Of course, the Japanese government has already realized that advanced energy-related technology are so important, and therefore more than 20 years, Japanese government make also good support for the development of such energy-related technologies. You may also see that there exist almost 21 energy-related technologies, and you can see that fuel cell vehicles is also key technologies in automotive applications, and also application in the residential sectors. Stationary fuel cell is also very important technologies. And you can also see the cutting-edge energy technologies, hydrogen-related system are actually the very promising technology in the future. You of course know that after the Fukushima disaster, the importance of these energy technologies become more and more important, and especially we have only the 2 nuclear power plants operating. So that at least in next few years or maybe longer, we also manage the electricity supply using the fossil fuel-based technologies. We have other promising technologies, fuel cells, and I want to just shortly mention what could be also available in these fuel cell technologies. Hirose-san has mentioned that for automotive application, the polymer electrolyte fuel cell is very promising, where the proton conducting membrane is used. For the residential application, but also for the large-scale power generation, high temperature fuel cell or the solid oxide fuel cell is very promising. And there exists also other type of fuel cell, including multi-carbonate and phosphoric acid fuel cell, and for special application like space application. For example, alkaline fuel cell are very important technologies. We are very happy to work in such environment in this country, because the true commercialization of the fuel cell has already been started. And compared to the other countries, it is very exciting to work in that environment. Of course, the fuel cell, commercial residential fuel cells based on the polymer electrolyte fuel cell has already been commercialized in Japan since 2009, and we are very happy that people has more and more interest to install this fuel cell technology at each houses. And actually, more than 10,000 units has already been sold since April this year. Usually, the electric efficiency of such system is approaching 40%, and including the heat and electricity and heat. efficiency is approaching actually the 90%. That means we just used almost 90% of the initial chemical energy into the either electricity or the heat demand. We are very happy that through commercialization of solid oxide fuel cell has already been started in this country. This is a picture, and I was also very happy because my PhD thesis is on this solid oxide fuel cells. And 20 years ago, I don't realize, you could not well imagine how such system can be realized, but 20 years later, after my PhD study, we can just buy actually such high temperature fuel cells. And I just heard yesterday that actually the more than 2,500 solid oxide fuel cell is actually already sold actually in this country. You may also see that electric efficiency of such system is now beyond approaching 45%, and the newest one has also efficiency of something like 46.5%. Of course, the fuel cell can also contribute to the other applications. Especially we in Japan, we have the serious problem in the energy supply and the electric supply, and we need actually good technologies for electric power generation. I'm very sorry that this is still the German slide, but you can see that energy technology like gas turbine and steam turbine are of course widely used. And the current advanced one is actually the combined system with the gas turbine and the steam turbine. You can also see that the fuel cell can also show the high electric efficiency, even for the lower power output. That means this type of system is very helpful as a distributed power supply system. I want to mention that solid oxide fuel cell is not so making the competition to such an energy system. Actually, we can combine the solid oxide fuel cell with the gas turbine and the steam turbine so that we can also prepare the so-called triple combined system, which can actually theoretically approach the electric efficiency of more than 70%. This is very challenging technology, and I think that could be the ultimate power generation technologies. As a material scientist, of course, there are also many interesting issues related to fuel cell. And of course, even though Mr. Hirose showed that they have the very advanced technologies, but still there are also many issues, and we should also see and understand actually the durability, determine the lifetime of the fuel cells. And besides the durability issue, we should also increase, for example, the electric efficiency, or of course, using the materials which can also realize the cost reduction on the fuel cell systems. And especially the electrochemical reaction is taking place at the electrodes, so that we have also focus for the electrode materials, and also interface between the electrolyte and the electrode. I just want to mention as a case study what we have done in the recent years. And I should also mention at first on the high temperature fuel cell research. High temperature fuel cell, as I have mentioned, has just, the commercialization has just started, but still they have clarified actually, or guaranteed actually the durability up to 5 years. But of course, for the true commercialization, we should also ensure that, for example, lifetime of the 10 years. Otherwise, nobody can also buy such system. Since several years, we have made systematic work how to understand the degradation mechanism, or better to say it, how the lifetime is determined. We may also clarify and categorize such the degradation mechanism into the this way. And what we have found is, for example, the interdiffusion phenomena, which is also very important. Especially some ions like the calcium can easily diffuse through the grain boundaries, and even through the electrode into the electrolyte. And that could be also cause sometimes a serious problem in the degradation. Other typical degradation phenomena determine the lifetime is the solid-state reaction, and especially we very often found the reaction product, the strontium zirconate in this case, and strontium zirconate is a very good insulating materials. That means if we have the insulator between the electrolyte and the electrode, of course, this insulator blocks the current transport, and therefore we should also minimize such the insulator formation. And we have also recently found that such the insulating product can also grow during the operation. Therefore, that could be actually the important topics to ensure, for example, 10 years lifetime. We also found that the sintering of the catalyst materials, in this case nickel, is also very important. And of course, we should also manage to keep actually the microstructure during the high temperature operation for a long time period. We have also found that dopant in the electrolyte can also dissolve into the grain boundaries. And that can also cause a problem, for example, during the cycling, and that must be also prevented. Of course, we have clarified actually such degradation mechanism determine the lifetime. But the challenging topic is, of course, a degradation issue at high pressure. Because as I have mentioned, combined cycle of the solid oxide fuel cell and also gas turbine and steam turbine could be the ultimate energy technologies. But actually, nobody knows how such process can be also going on at the high pressure operation. This is a very challenging topic, but we have now the national project, and we want to understand actually the mechanism even on the atomic scale. Other issue, especially for the carbon neutral fuel cell, is that we should also work with carbon neutral renewable energy resources, like, for example, biogas, beside hydrogen. In this case, we have also many contaminant problems because impurities can also come into the fuel cell, for example, from the fuel side, but also air side, and also from system component. And we have also clarified actually the mechanism associated with the microstructure change. Of course, we have now the advanced facilities so that we may also understand more details on the atomic scale and also sub-nano scale in the future. And we hope that we may also work to develop the actual fuel cell, which could also help for carbon neutral energy society. For the high temperature fuel cell, low temperature fuel cell field, of course, the first generation of the material has well developed. That is the reason why Toyota could also produce very good fuel cell systems. But of course, the university group, as a university group, we are working not for 2015, but we are working for 2020, 2030, and beyond. Still they exist, even though the fuel cell, polymer electric fuel cells were advanced and commercialization has already started, but there exist also many fundamental issues, including, for example, the transport phenomena, but also catalyst, but also, for example, in situ characterization techniques. In the cell level, of course, there are also many important issues like the electrolyte. For example, it is very nice to have the electrolyte which is suitable for high temperature operation, low humidity operation, and so on. For the catalyst, electrocatalyst, and also electrocatalyst support, there exist also several important issues. Of course, a low non-platinic electrocatalyst is also a very challenging topic for 2020 or 2030. But we have also serious problem with a long-term durability issue, which is determined actually the lifetime of the fuel cell. So that especially stability against the voltage cycling up to the higher voltage is also very important and essential. You may also see other issues like performance improvement and also system issue, which could also make the fuel cell more available and also low cost. Since several years, automotive company made also many demonstration program, but through this project, they have learned that what could be actually decisive mechanism the degradation mechanism, which actually show the degradation of the fuel cell vehicles performance. That is actually the slide presented by, I think, the Nissan and group. They have clearly shown that the start and stop cycling is cause actually almost half of the degradation of the fuel cell vehicles. And therefore, the NEDO had also set the target that 60,000 cycling up to the higher voltage must be also survived, and that is correspond to the lifetime of the fuel cell vehicles. And therefore, we have started to work with the electrocatalyst issue, and we want to solve such problem. And this is actually a typical micrograph of the electrocatalyst. Of course, we have the small particles of platinum with a diameter of 3 nanometer. And these platinum nanoparticles are dispersed on the surface of the carbon black as a state-of-the-art conventional electrocatalyst. Now we have actually three different possibilities and strategies. One is, of course, typical method which is widely used, for example, in automotive companies, graphitizing the carbon support. This is the straight-weight solution. At the university group, we are working because there exists also other very interesting materials, for example, alternative carbon materials, because we have now a good team where Hayase-sensei is working with the nano mesoporous carbon. Stephen sitting there is working with the graphene, and these are very challenging materials which could also may solve many problems. I'm also personally working with the no carbon support because if we developed the electrocatalyst without the carbon, we are free from the carbon corrosion problems. And that was actually the way that we have developed at the beginning of the I²CNER project. Now we have the very small particle of platinum, of course the diameter of something like 3 or 4 nanometer. But this case we use actually absolutely no carbon. That means that the materials behind is actually tin oxide, non-carbon materials, which has also very good electronic conductivity. Now at the beginning of the I²CNER, we have shown that this catalyst materials is relatively stable, but at the beginning we have shown this durability using the powder samples. And last year we have shown that we can also show the durability using the MEA. This is in progress, but the performance was not satisfactory. But now we are very happy to announce you that we presented these new results last week. That now we can also show the very more stability, and even after the 60,000 cycling corresponding to the lifetime of the fuel cell vehicles, we can also retain actually the cell voltage of the 85% of the initial value. And this is great improvement, and we also show the compatible electrochemical performance compared to the state-of-the-art platinum carbon electrocatalyst. And therefore, now we have shown that this material could be stable from the materials viewpoint, and also stable in the MEA, that is actually fuel cell, and showing not only the durability, but also the comparable performance. I want to mention what we are planning, because we are still the preparative initial stage of this I²CNER project. And I want to inform you how we have prepared, especially for the fuel cell research in the future. There exists actually many fundamental issues already not yet clarified. For example, from the understanding viewpoint, we are working with the polycrystalline materials. That means we have the device with many interfaces. Of course, electrolyte, electrode interface is key, but also grain boundary is also actually the key point, determined actually very often the physical properties. And therefore, we want to understand actually what is going on at the interface. And the other issue is we have now the advanced facilities so that we may also understand more the atomic scale or the molecular level, and also sub-nanometer scale characterization. It's also helpful to understand actually microscopic mechanisms. There exists also some, there is also tough discussion going on the, for example, nanosize effect, because if you have the particle so small, our material is almost full of the interface. And that could be also interesting topics because the then interface actually dominate the material's properties. In the materials issue, there exist actually, I think, the three challenging issues, including the low temperature solid oxide fuel cell and high temperature polymer electrolyte fuel cell. That is also helpful, for example, for automotive application. And we have just started the project to understand the high pressure fuel cell, because that is really essential to realize the triple combined power generation system, and which is helpful for large-scale power generation. There exists also other issues like robustness, flexibility, and durability. And carbon neutral is, of course, a very important topic. And we all should also understand how actually the lifetime is determined. I²CNER gives actually the good framework for the fundamental research, because there are also many other research groups working also to understand the interfacial properties. And especially, we should also contribute from the basic science viewpoint to the other topics, because the fuel cell is actually dealing with many interfaces. And of course, without fuel cell, we cannot realize the carbon neutral hydrogen-based energy society. Thanks to the WFI program, we have already established a truly international team. Now we are very happy that we have good colleagues, and Dr. Bischoff is also working to collaborate, accelerate the collaboration between MIT and Kyushu University. Professor Gewers is a good famous person in the electrocatalyst in the University of Illinois, and we have also good collaboration. We have the good collaboration with Imperial College London, and Professor Gaukra is also strongly involved. And we are also very happy that Dr. Shingal, the very famous person in solid oxide fuel cell, is also this year a visiting professor of the Kyushu University, so that he will also give the special lecture in next month. In this project, of course, fusion is very important, and actually, even we see in the fuel cell field, people are talking with the different languages. If someone working with the low temperature fuel cell, they are actually working based on the liquid phase electrochemistry or the classical electrochemistry. High temperature field, very often we are working with the solid oxide physics or solid oxide chemistry background, and we want to integrate actually the electrochemistry. And that could be also helpful to establish the fundamental science related to these energy conversion devices. Since several years, we have prepared to establish the world visible research center. That is the very important issue, as Professor Dr. Kuroki has mentioned. We have a chemical laboratory, microscope laboratory, durability test laboratory, and fuel cell test actually the factories. And we are very happy that we succeeded to get the external funding to actually establish the new research facilities. And actually on this fourth floor, we will open the MIT office, laboratory, and Imperial College London lab, and also ETH laboratory. This floor is very open for the international open fundamental research area. And on the second floor and third floor, on the fuel cell side, approximately, I think the more than 10 private company has decided to open the office. And this is very challenging because we can accelerate industry academic collaboration. We can also learn so much from such collaboration, and we found also many issues which could also helpful for the basic science research. And on the first floor, we have the advanced facility. We'll also get advanced facilities, and we are very happy that these instruments we also installed in this month. including atomic resolution scanning transmission electron microscope, so that we can make the atomic scale characterization of the fuel cell. We are very happy that low energy ion scattering, that is only one best apparatus in this field on the world, which make also atomic scale surface analysis possible. We are very happy that, for example, non-destructive technique must be also developed and established for the future research. And I would like to mention that such collaboration make also such the actually that we have also established actually the one comprehensive research platform, so that the basic science research can be also made in the, of course, in the I²CNER framework. And we have also facilities where we can also make the collaboration with the private companies, and this understanding through such collaboration can also put again to the basic science. And all these issues from fundamentals to the society and can be also made under one roof. That is what we have prepared for future research. And of course, in Kyushu University, we have also many facilities already established, and we are happy that we will be very strong in the hydrogen and fuel cell research area. Before we close the presentation, I would like to mention again that fuel cell is not just one technology, energy technologies. Because this year is very important year, because just really 300 years ago, steam engine has been invented. What we have done since 300 years that we combust and burned the fossil fuel so much, and that is the reason why we have many problems with the Earth's environmental problem, but also energy problem. And based on the gasoline engine, automotive industry has established, but we are, of course, facing many problems, for example, including energy and also environmental problems. Now, using fuel cell, which make the chemical conversion possible, of course, we can can also generate electricity at home, and also fuel cell vehicles are helpful, as here mentioned, and also power generation area. We can also fuel cell can also contribute. And we hope that I²CNER fuel cell group can also contribute so much for this revolution or in energy sectors. And we hope that we can also make a contribution to the sustainable mobility, but also sustainable energy supply, and also comfortable daily livings. Before I close the presentation, of course, the WPI program, we should also get also many external funding. That is also requested, so that the professor must also try to get the other external funding. And I would like to thank, beside the WPI program, many other projects like the Kakenhi and NEDO project, and so that we can also make the research in progress. Thank you very much for your attention.